As I discussed earlier, I'm going to cover ray diagrams from light. Already I have started it, and now I get inside the rays of light when it passes through prism, especially the ray diagrams which are asked in ICSE and CBSE. In prism, there are different kinds of ray diagrams where the questions are asked like this, that trace the path of the ray as it passes through the prism, namely equilateral prism, right-angled prism, okay, isosceles right-angled prism. Both the numerical parts, I won't say it's numerical, but it is. In case of ray diagrams, you have to trace the path of the prism, keeping certain aspects in mind, that what is the value of critical angle, how does total internal reflection occurs, all these things. Okay, so let's proceed for that. In these two cases, the question will be like this, that trace the path of the ray as it passes through an isosceles right-angled prism or an equilateral glass prism when it is incident normally on the surface shown in the diagram. Okay, so one by one we shall proceed for that. First, the ray which is incident on AC, since its normal incidence here, it will pass undeviated. Okay, so this is 90 degree. As you can see, if this is an isosceles right angle prism, this is 90 degree. These two angles have to be 45 degree. It's understood. Okay, now if this is 90 degree, this is 45 degree, triangle created here will have an angle 45 degree here. Now, as you see, if this is 45 degree, where the light ray is incident, at this point, I shall draw a normal first. This is normal. If this is 45 degree, this again will be 90 minus 45 will be 45 degree. Now, it's very well known to you that for glass prism, critical angle, okay, is 45 degree for glass. 42 degree. Okay, sorry. 42 degree. All right. Now, your angle of incidence is 45 degree, which is greater than the critical angle 42 degree. That is, angle of incidence is greater than the critical angle theta c. 45 degree greater than, obviously, 42 degree. So what will happen to the fate of this incident ray? It won't be able to come out on this surface. I mean to say, it won't reach air from AB. It will bounce back from surface AB obeying ordinary laws of reflection. That is, what will occur over there? Total internal reflection will occur. I am just explaining it to you. During exam, you don't have to write all these things. You'll just show the angles and you'll mention critical angle is 42 degree for glass air interface. Therefore, from surface AB, total internal reflection occurs. That can be sent as a note, written as a note, once you face this kind of a problem. Otherwise, only tracing the path of the ray is important. Okay, so it obeys ordinary laws of reflection, and this again becomes 45 degree. Now, if this is 45 degree, this is normal, this angle again has to be 45 degree, isn't it? So this is 45 degree, this is 90 degree, again this is 45 degree, since sum is 180 degree for a triangle, the sum of internal angles. At this point, again you have to draw the normal. Drawing the normal is very important, otherwise you won't get the angle of incidence. If this is 45, again this has to be 45. And again, from glass to air interface, the angle of incidence exceeds the critical angle. So the ray of light again bounces back. So this is 45 degree. So the angle of reflection here after the total internal reflection occurs at this point is 45 degree obviously, and the ray of light comes here. So let us see what kind of incidence it is here. This is the normal. This is 45 degree again. Okay. And this is 45 degree because you took an isosceles right angled prism. This is 45 degree. So if this is 45 degree, this has to be 90 degree. So the final angle of incidence, you can say it is 90 degree here on this surface. So now you call it emergence. So when this ray of light reaches at this point, it will pass out undeviated. So what we get is the incident ray and the final emergent ray, they become parallel to each other. Okay, and it all happens due to total internal reflection that occurs at these two surfaces. Okay, so this is how you trace the path. When it is called trace the path of the prism, then you have to remember that you have to mark the angle of incidence and angle of reflection at each point. Only then you will be able to show that the final angle of emergence at this point is 90 degree, due to which the ray goes out from the glass to air without any deviation. Okay. Now we come into equilateral glass prism. In equilateral glass prism, what we have is each and every angle here is 60 degree. You know, it's equilateral glass prism. So here, when an incident ray comes like this, it's a normal incidence again. You know, upon normal incidence, this will pass undeviated. Okay. And passing undeviated means this again will be 90 degree. This is 60 degree. So obviously this angle has to be 30 degree. Since sum of the internal angles of a triangle is 180 degree. Okay. Now at this point of incidence, you draw a normal. As soon as you draw the normal, this angle of incidence at this surface becomes 60 degree. Again, you know, from glass to air, the ray of light, when it is trying to come out of this refracting surface, it is moving from denser to rarer medium, and in the denser medium, the angle of incidence is 60 degree. Again, 60 degree is greater than obviously 42 degree. This 42 degree is the critical angle, and since such thing happens, we have again a total internal reflection. That is, here the angle of reflection again is 60 degree, because total internal reflection also obeys the ordinary laws of reflection. So what you have is the ray of light bounces back, suffering total internal reflection. If this is 60 degree, this is 30 degree, obviously. This is 60 degree. So what happens here? It is again 90 degree. So here on this surface, the ray of light is incident normally and hence passes out undeviated. So this is the path of the ray while it passes through an equilateral glass prism. Again, here also you have to mention all the angles of refraction, all the angles of incidence and reflection in case of the total internal reflection. I hope this was of help, and further we are going to discuss some more ray diagram problems that will be of immense practice and help for you. Please subscribe to my channel and help me help you. Thank you.